Welcome to the Slop Farm. Enjoy the video.
You start by installing LibROSA, NoiseReduce, NumPy, and SoundFile, then load your WAV or MP3 into Python. Use LibROSA. Load with SR equals 44,100 to keep quality consistent. Once loaded, plot or inspect the waveform and listen to a couple of seconds to find a noise-only region. Select a clean noise sample. 2 to 5 seconds works well, because that profile will teach the algorithm what to remove. Make sure the file is mono or converted to mono. Next, extract the noise segment array and compute its spectral characteristics so the reducer knows what to target. Call NoiseReduce. Reduce noise, passing the full audio and the noise clip you extracted. Set stationary to false for speech or variable noise. Tune prop decrease to control aggressiveness. Lower values keep more signal, higher values remove more noise. If you hear musical artifacts, enable time mask smooth MS or adjust time masking. Those smooth the reduction across time and reduce warbling effects. Apply the denoising to the whole clip and write the result with SoundFile. Write at the original sample rate. Once done, perform a /B listening and view spectrograms to confirm noise reduction without harming the target signal. If you detect pumping or musical artifacts, make sure to lower prop decrease and try smoothing parameters, or switch to spectral gating with a lower threshold. Finally, export at the same bit depth. If problems persist, reselect a cleaner noise sample and repeat the process.
Thanks for watching. Consider subscribing if we helped you today.